In this lesson, we're going to start with a quick review of some of the linear equation basics we've gone over and then introduce point-slope form. So, looking at a little bit of review, we have linear equations review first. So just to recap, remember that linear equations form straight lines in any direction. The solution of a linear equation is any ordered pair that makes the equation true. Remember, ordered pair is just a fancy word for a point. So any point that could go into that equation and make it true is considered a solution for that equation. Linear equations can be written in standard form where A is positive, A, B, and C are integers, and not all equal to 0. So you can't have all the coefficients be 0 in your equation or standard form. So we use standard form. Anytime we have an equation at all, we can transform it to standard form. And if we can, I should say, then we can confirm that the equation represents the equation of a line. Quick review of slope. Remember, it is the change in y's divided by the change in x's. That is equal to your slope, m. This helps us find the slope between any 2 points. The slope is found by calculating our rise over our run, and it describes how steep the line is. Finally, remember that if your line is going up from left to right, the slope is positive. If the line goes down from left to right, the slope is negative. And finally, we've learned a second form of linear equation, which is slope-intercept form. That looks like y equals mx plus b, where m is the slope and b is the y-intercept. So any linear equation can also be written not only in standard form, but in slope-intercept form. Slope-intercept form is really nice for graphing. So remember that often in the problems we were looking at in our last few lessons, to write our equations of lines, we would often need to find the y-intercept. So to do that, we would need a slope and a point or 2 points on the line, and then we would fill in whatever information we had to calculate for that b that was remaining, our y-intercept. So this brings us today to the third linear equation form, which is point-slope form. And the formula for point-slope is y minus y1 equals m times x minus x1. What I really want to reinforce here, and I've got it here in capitals up here, is, ooh, my board's going crazy, is that our point-slope form is named really for what's in it, 1 point and a slope. Just like slope-intercept had a slope and a y-intercept in it, point-slope has 1 point and a slope. So often we're going to use the names of these linear equation forms to help us determine which form would be best to use. If we're given a y-intercept and a slope, then it would make sense to use slope-intercept form. However, if maybe the y-intercept is missing and we have a point and a slope, this might be the better type or form to use. So in point-slope form, m still stands for slope as always. And x1, y1, these values each represent the coordinates from one of the points on the line. And so x1 and y1 should come from the same point on a line, and they will be numbers when we're done writing our equation in point-slope form. The first y here and the first x will always remain y and x when we finish writing our form, because those will represent the infinite points that could go into the equation of this line. I want you to notice the piece of information that we don't need, that we did need in slope-intercept form, is the y-intercept. So one of the things that's really nice about point-slope form is that if you don't have your y-intercept, that's okay. You can still write the equation of the line using this form instead. So if we are in class, we would watch a video on the idea behind point-slope form. But what I want to show you is just the main takeaway from this video. So really, and I think it's kind of cool, point-slope form is just a manipulation of a formula we already know. I've done here is I have written the equation for slope, and I want to show you how point slope form is really just a manipulation of this. So the slope formula, remember, is the change in y's divided by the change in x's, your rise over run. In the video, it's a Khan Academy video, so Sal Khan goes through explaining that what we can do to simplify this equation is multiply through by the common denominator. So if you'll notice, we have a big fraction. It's not a pretty looking fraction. We have a big fraction there equal to m. It is an equation because we see this equal sign here. And so to simplify this, we might get rid of our fraction by multiplying through by the denominator. Well, the denominator is this whole expression x2 minus x1. And so what I could do is use that denominator to multiply through and get rid of the fraction. But what I do on one side, I have to do on the other. Now, I should note that this is some higher level algebraic work that we're doing right now. You wouldn't be expected to know how to multiply through by a binomial as this is in our class, but this is a process that we could do because it's a denominator, that whole thing we can multiply through by. Well, on the left side, when I'm multiplying through by x2 minus x1, remember we can think of that as being over 1. Anything over 1 is itself divided by 1, right? So these will cross simplify and therefore divide out to be 1, which means that they go away because we don't need to write them if they're just 1. So that leaves us with just the numerator equal to m times what used to be our denominator. And this really is point slope form without the extra little subscripts on the first y and x. So I thought it was a kind of a pretty cool thing to just see that point slope form is really just manipulating slope formula, and it's nothing too different from what we've already been working with. So let's get to work using it. Here you've got the equation of a line graphed with 3 separate points on that line given to you. Now remember, these are just 3 points given to us, but how many points are actually on a line? Infinite, right? Lines go on forever, and you could take any point on these lines. I do recommend using points given to you because those we know to be exact points, meaning we didn't have to guess as to where that intersection occurred. Okay, so to write the equation of this line in point slope form, we've got to do a couple things. Point slope form means we need a point and a slope. Well, from the graph we've been given, you can see clearly that we do have 3 points, but we don't have a slope. So we know we have a point, we need a slope. So step 1 here is going to be to find our slope. Now, because this one's given to us graphed, you could find your slope by counting it out. Rise over run, 1, 2, 3, 4. And we run 1, 2, 3 to the right. So our slope is positive 4/3. Or if you prefer using the formula, just take 2 of the points, subtract your y's, and subtract your x's. Once you've got your slope, label it as your slope and circle it. Any key information, remember, we want to be circling and labeling so that when we need to use it later, we're not having to search all over our paper looking for it. Okay, so we've got a slope, and point slope form, we need 1 point. So step 2 is to choose 1 point. All of these points are on the line, so you have freedom in which point you use. It is up to you. So let's start with, let's just use this point, 6, 4. Notice I circled that one. I'm using red right now, so I circled that one in red. I'll go ahead and erase this one that I was talking about earlier. So there's no confusion. So we're using the point 6, 4, and our slope is 4/3. I do recommend labeling x and y, our x1 and y1, again, so that when you're going into your point slope form, you're not mixing values up into the formula. Lastly, we'll substitute the slope and the point into our equation. So if our equation, and this is a good habit to be in as well, please start by always writing the equation you're using because you will be needing to memorize this. So y minus y1, our y value in the point is 4, is equal to m, which we found to be 4/3, times x minus x1, which is 6. And what's nice about this, well, not my board is being funky. All right, what's nice about this is all we have to do, and we have just written the equation of a line. And so this is point slope form of this equation, and you would be done. Now, there are two other points given to us. So I want to show you that if you had used, let's say, the point 30, that still would have worked. So y minus 0 equals 4/3 times x minus 3. This is another correct equation for this line in point slope form. And let's show that it also works for this last point, 0, -4. This one has something interesting in it because one of the coordinates is negative. So I want you to pay attention to what happens to it when we put it into the equation. So when I do y minus y1, can you see that our y value in the point is -4? So I would need to write this as y minus -4. And a minus a negative, hopefully you recognize that as just being addition. So preferably, we would then change that to a y plus 4, okay? Equals, our slope is 4/3 times x minus 0. And with the zeros, you can just leave them there, just as they are. You don't need to simplify. Leave it right at it as it is, and that way you can clearly see the x value was a 0 and the y value in that scenario was a -4. So as I said, all three of these are correct equations for this line. You might be looking at them saying, but they look different, right? And they do look different because we've used different points. However, because all of those points are points on this line, any point that you use that is in fact a point on the line will be a correct equation for us today in point slope form. So one way that we could check this, remember, we can transform equations of lines into other forms. And what would be really cool about this is if we transformed all three of these equations to, let's say, slope-intercept form, we would get the exact same equation. As well as if we transformed all of these to standard form, you would see the exact same slope, or A, B, and C values. So that would prove that these are all correct equations to this line. But I and any teacher would accept any of these equations written as the equation to this line. So let's practice one. That last one was nice because it was all graphed out visually for us. Let's look at one that's not. So here we're writing the equation of this line that has the point 4, -6 with a slope of -1/2. Now remember, label important things. And always start by writing the equation you will be using. In a moment, we're going to be incorporating point slope, slope-intercept, and standard form. So labeling what you're using is going to really help you stay organized in your work. All right, so now we're filling in. Our -6 goes into y1. Our 4 will go into x1. And our -1/2 goes in for our slope. Now, when I do y minus a -6, you'll see two negatives is equal to addition, equals our slope of -1/2 times x minus our x1 of 4. And that is the equation of this line in point slope form. All right, for this next problem, we're going to write the equation of the line in slope-intercept form. And we've already done problems like this, where we're given a point and we're given a slope. However, today I want to push us to use the point slope form. So earlier what you would do is you would substitute the x and y from your point into slope-intercept form, and you would put the slope in as well for m. And we would be missing the b, the y-intercept, and we would solve for b, and then we would go back and rewrite the equation in slope-intercept form. But because we have a point and a slope, I hope you can recognize that the most natural linear equation form to write in would be point slope form. So let's start there. Let's start by writing this in point slope form. Take a moment, set up your point slope form equation, and fill in these pieces of information into it. So go ahead. So just to check what you've done, we should be doing y minus y1 equals m times x minus x1. And so our y1 is 2, our m is 1/5, and our x1 is a -5. So minus the -5, I can look ahead and see that will be plus. So I'm writing that as a +5. This is our equation in point-slope form. Now, what we've been asked for is to write it in slope-intercept form. What would be good is to jot down that our end goal is y equals mx plus b. That's where we want to go. And I hope you notice, or have already noticed, that when we write equations in slope-intercept form, that really means isolate y. Get y by itself. So what we'll do next is transform from this point-slope form to slope-intercept form. And really our goal is isolate y. Now in this equation, we do have some simplifying that needs to occur first. Hopefully you see this 1/5 needs to distribute to the terms after it. So always distribute first. Bring down the rest of your work. And work to isolate y. Oh, why did I write a 3? Woo, sorry about that. I was thinking ahead. All right, so this will give us a 3. There we go. And once you isolate y, you have your equation in slope-intercept form. So it's kind of neat because we never actually had to solve for the y-intercept. By doing our transformation, it ends up kind of just appearing at the end, that ends up being our b, our y-intercept. So what I have here is the method I just showed you on the left, and then this over here is how we were doing it before we had learned point-slope form, just to prove that both give us the same equation. Later in this unit, you'll be allowed to use the method that you find works best for you. Today, though, we're going to push ourselves to use point-slope form, and a lot of you will find that this is a much nicer equation form to use when appropriate. Okay, let's look at our next example. Write the equation of the line in standard form. So remember, standard form, we should jot that down right as soon as we read that that's where we want to end up in, so that we don't lose sight of our end form. Is ax plus by equals c. Remember, there are some rules with standard form, like a must be positive, no fractions or decimals, and a, b cannot both be 0. So we are given the x-intercept of -2 and a slope of 3. Well, right here, remember we want to label key information. We're given our slope of 3, so I'm going to jot down m equals 3. But then that brings us to this other piece of x-intercept of -2. So we have to think about what is an x-intercept. Well, hopefully you can recall that it's nothing more than just a special point. It's a point actually on an axis, and an x-intercept is on the x-axis. So this can be written as the point to 0. So by doing this and writing our x-intercept as a point and seeing our slope, hopefully you recognize we are given point-slope form. So I want you to take a moment and write these pieces of information into point-slope form. I guess we could set it up together. Let's set it up together, and then I'll let you go from there. Oops, x1. There we go. Okay, so filling in minus a -2 is really +2. Okay. Remember, we want to end in standard form, so I'm going to give you a moment now to take this equation, remember, distribute first, simplify, and get all the way to standard form this time. So go ahead, pause the video, work through this. When you're ready to check, click play. All right, so hopefully you have transformed this equation. Distributing first, y minus 0 is just y, and then we get to this point here. Y equals 3x plus 6. Here is the slope-intercept form. And you will find that often you do need to go through slope-intercept form before you get to standard form. Getting your simplifying all done takes us usually to slope-intercept form. So from there, you need to transform to standard form, meaning you need your x and your y term on the same side. So I subtracted 3x from the right and brought it to the left. Anytime we cross the equal sign, we undo the operation. Then we had to multiply through by the -1 because that had left the a value negative. So multiply through by -1, and that leaves us with 3x minus y equals -6. And that is our equation in standard form. And so we're finished. Okay. For the rest of today's lesson, we're doing a lot of these different kinds of transformations. So in this next example, we're writing the equation of the line in slope-intercept form. As soon as you read that, jot down that that means we want to end in y equals mx plus b. Always give yourself that visual of where you want to end. We will get usually caught up in the work, finding our slopes and writing our equations of lines, and then we maybe go too far or not far enough in our transforming. So this one's a little bit different because we're given 2 points. We are not given a slope. So because we're given 2 points, though, we do have enough information to find our slope. What I want you to pay attention to as you're finding the slope in this problem is that there are decimals. So pause the video, find your slope. When you're ready to check, we'll come back together. Okay, so hopefully you have set up your slope formula correctly, and you are not done with finding the slope until you have gotten rid of your decimals by multiplying top and bottom by 10. Remember, this is really just 1, which is why we're allowed to do that. Anything times 1 is itself. That gives you -55 over 15, which then reduces. So here is our slope of -11/3. I hope you now can see that we have a slope and we have actually 2 points. So remember, when we are writing into point slope form, which would make most sense because we don't have a y-intercept, let's use point slope form, you only need one of the points. So take a moment and choose a point. I usually choose the one with smaller numbers or easier numbers, so I'm just going to use 2, 1.5 as my point. You certainly could use 3.5, -4 as your point. It's up to you. Please label your x1, y1. And I'm going to let you, well, let's do this one together because of decimals. We will then replace the x1, y1, and m with those values in point slope form. So take a moment, y minus y1, is what I've got here, equals m times x minus x1. Okay, from here we need to get into slope-intercept form, which really means isolate y, get y by itself. Right. And to do that, we're going to need to distribute and move this -1.5 over to the right side. Now, I hope you notice that we've got both fractions and decimals in this equation. And whenever that happens, we will need to convert all of our rational values to the same form. So that means we either need to make them all decimals or all fractions. Now, in this scenario, you can see that we have one of our one fraction has a denominator of 3, -11/3. If you think about that, a denominator of 3 implies a repeating decimal. So because 11/3 repeats as a decimal, it is impossible to write that value on the paper as a repeating decimal going on forever. So that one actually needs to stay as a fraction, which means -1/5. We will need to convert to a fraction. We can't use decimals in this scenario. So I'm going to come over here. -1, did I say -1/5? I meant -1.5. So -1.5, remember, to convert a decimal to a fraction, you just need to read it properly. So -1 and 5/10 is really what this says. We would then reduce to -1 and 1/2. And it is going to be easier to work with this fraction as an improper fraction. So let's go ahead and make that final transformation in -3/2. Okay, so this is the fraction equivalent to -1 and 5/10. So I've transferred that and written it as 3/2. And then we have -11/3 x minus, times the negative, which makes it positive, plus 22/3 when we distribute it on the right. From this step, we've got a variety of fractions in our equation. So you can see here in red, I'm going to choose to multiply my equation through by a common denominator. My denominators were 2, 3 and 3, so they all go into 6 cleanly, so we'll use 6. This, if we do this step properly, will get rid of all of our fractions. Take a moment, multiply through by 6. Okay, and we would get 6y minus 9 equals negative 22x plus 44. This is a really nice step getting rid of fractions because from here it's pretty quick work to isolate for y. We're going to add 9 to both sides and then divide everything by that 6, leaving us with y equals negative 11/3 x plus 53/6. Or you could convert that last y-intercept to a mixed number. You certainly don't have to for my class, though. You can always leave them as improper fractions as long as they are simplified. That's probably one of our more involved problems because of all the decimals and fractions in it, but certainly we have the skills to be able to do that. Okay. Oops, I didn't mean to reveal that, but here's our next scenario. Write the equation of the line in slope-intercept form. Given an x-intercept of 5 and a slope of -1/2. So I probably should have had this covered up, but we've already talked about it anyways. Remember, an x-intercept of 5 is really just the point 50, and a slope of -1/2 can be written as m equals -1/2. So you can clearly see we have point slope form given to us. Go ahead and make this transformation to slope-intercept on your own, using point slope if you can, and practicing with that. All right, so if you're ready to check, let's do that. If not, just click pause and finish working this out. Okay, so filling into point slope form, y minus 0 equals -1/2 times x minus 5. Distribute first. And the y minus 0 is really nice because that just goes away and we're done. All right, here's another one, and this one's going to standard form. You are given 2 points, and we need to start by refreshing our memories or writing down where we hope to end. Standard form is ax plus by equals c. So take a moment now. This scenario, we need to not only use a point. We're not given the y-intercept, so it will make more sense to use point slope form, but we'll need to find the slope and use one of the points. So take a moment, do this one all on your own. When you're ready to check, click play after pausing. Okay, so hopefully you have made your full transformation of point slope form. Starting out with finding the slope to be 4/5. Subtract your y's, divide it by subtracting your x's. Then use one of the points, and I chose the point 2, 1. It would be perfectly acceptable if you use the point -3, -3. That is up to you. We will all get to the same place if your calculations are correct. But I use the point 2, 1. Next, we distribute and add the 1 to both sides. Now, at this step here, you may have chosen to multiply through by 5 to get rid of your fractions, which is excellent. If you did recognize that adding 1 is the same as adding 5/5, and you saw -8 in the numerator, so -8 plus 5 in the numerator gave -3/5, great. If you're comfortable with adding fractions like that in your head, you can go for it. So from here, we need to get, this is our slope-intercept form, what's in green. We need to get to standard, which means get rid of fractions and get x and y on the same side with x being positive, a being positive. So we should all end at 4x minus 5y equals 3. Okay, and for this next one, very similar. I'll let you go ahead and work through this one. We're given the point -4, 3 and 1, 0. 2 points. We want to end again in standard form. Take a moment, find your slope, set up point slope, and transform. Click pause. When you're ready to check, click play. Okay, slope between these points should have been -3/5. Filling into point slope form, I use the point 1, 0, again, using the one with smaller, easier numbers. Distribute first, and then we can't have fractions in standard form, making sure to get x and y on the same side with a's value positive. And that is the end of our lesson. So hopefully You are now going to be a pro at using point slope form whenever it's most appropriate. And we'll be practicing this concept for a couple days.